what are these yellow things here for? Your parameters, gain, tau, T0, and tau sub I. Gain, tau, and T0 is what I really want you to know for your system. Gain, tau, and T0. Steady state gain, time constant, and dead time. Tau sub I is what you get from one of those formulas. Change to one significant digit. And then here's this KC increment. You know, that's how much this increment's along here. So there's your Root-Locus. When you give your presentation, I'd like you to give the Root-Locus and have arrows point. Isn't that interesting? What do you make with those colors? You can take?
Yes,
when you do the algebra, you end up with a cubic equation. How many roots are there for a cubic equation? 3. So the blue represents one locus of roots, the green represents another locus of root, and this purple represents the third locus of the roots. But it doesn't matter. They're all roots. When you give your presentation or your reports, I'd like you to have this thing here and an arrow like that A pointing here as to what the value of the KC is that gives you that. And the one at 45 degrees, 70, 76, and ultimate. By the way, where this crosses the y-axis is the ultimate frequency. Dang! You know what the bad news? It's in radians per second or per hour or whatever. Radians. How many of you love radians? Raise your hand. How many of you know how to convert radians to something that's useful, like degrees? All right. How do you do that, Phil?
I forget.
That's 2 pi over 180, or there was reciprocal of that. 2 pi over 360. 360 over 2 pi. Pardon?
4 pi over 2 over 9.
Over 2 over 9. That's very well, except it's reciprocal of it. Because you want degrees on numerator.
Yeah.
All right, now then. So this seems pretty easy, doesn't it? Say yes.
Yes.
How can I make this smaller? Oh, there's a thing down here to make it smaller. I want to look at the graph while I change my tau sub I. So what I say, that's 2 significant digits. Let me change it to 0.1 so I'll make my customer happy. Okay. Did you see the graph change? Mm-hmm. Right? So now I'm going to multiply that by 3, let's say. Make tau sub I large. I'll use 4. I'll go all out. I'll use 4. I'll make this 0.4. What do you think is going to happen to the Root-Locus when I hit enter?
Go to that.
This looks similar to what? Proportional. Oh, who said that? Yeah. Because tau sub I is in the denominator of those formulas. The larger you make it, the less important that term is. So if you plug in infinity, you'll get exactly proportional control. You know, remind you of that? Say yes, Dr. McGee.
Yes.
If I make tau sub I very large, then this term is insignificant, and you have only this term. So that's why when I plugged in a larger number for tau sub I, began to look like this. What do you suppose is gonna happen when I plug in a smaller number of thousand on
It'll look less like that.
it? It'll look less like that. Let me go back to where I was. You remember where I was? 0.1, right? 0.1. And that's definitely not what it used to be. Is that it?
Yes.
Shall I try, 0.05? That's not a big step, that's only half as big, right?
It's two sick days.
0.5 is still one sig big.
Yeah, 0.05, 0.5.
0.05 is even one sig big. So let me try 0.5.
It's gonna make it bigger.
Am I doing this wrong?
Yeah,
Yes.
it's a big 0.05.
What did I have before, 0.1?
Yes.
Oh, okay, I'm sorry. 0.05. I thought it was 1.
Closer.
Shall I do 0.03? Two. Well, one. You don't have to do all these. By the way, let me see. There's a column in here. I'll move this over, but there's a column over here that says the imaginary part. There's the imaginary over real. So that's the, this value here is the, oh, here's the degrees over here. You see this over here? That's the degrees. So there's a column for degrees in there. Let me go back to 0.1. What's that?
You zero.
0.1. So there's the degrees thing that gives you about 45 degrees, 70 degrees. What was the other, 78 degrees? And here's KCU if you go down here somewhere. Right in here, where it goes from negative to positive. All right. So that's how you do that. I want you to fill out a table like this, submit it to me by, when?
Monday.
Okay.
What was that green box that you said you wanted it to get to 1?
That's a very good question. That's a very good question. Let me plug in a different number. Let's say 5 is the control gain. Look at that. Whoa. I think if I click goal seek, there may be a different name for that nowadays. What is it?
No, it's still goal city.
Where do I
It's
go?
under what if analysis. Data.
Data.
What if analysis? Go right there.
What if analysis? Goal seek. Set cell D7. By changing, set that to 1. By changing this one over there, D7. Didn't work.
Because you have to do B dollars times 7 to lock it in.
All
Do the goal seeking again.
All right, you see that number there? Way off, so I'm gonna change it manually to 1, see what happens. That help me any? 0.1. Ah, no, 0.01. So, I have to do it manually. Goal seek can be, brutal, is that what you said? Fickle. Yeah, fickle. I don't know how to make it any better, so I give it to you there. So, like for you, from the Root-Locus to give these values for the value of town survivors, the formula gives you. Do it again for a larger value of town survivors. And then another value of town survivors. Each of your Root-Locus plots, match that 100%. I'll do week 13 of it. Questions, outstanding questions? How to get your teammates to be conscientious?
Can we vote to become Switzerland, Dr. Henry?
Can do what?
Can we vote to dissent and become Switzerland?
No. Good try though. Good shot. All right, what am I gonna do for you? Am I owing you something?
Pizza, plant tours.
Oh, plant tour, no, that's passé. 2 weeks from today, we're gonna have our final presentations. And I'm bringing pizza from University Building. I assume everybody likes Hawaiian pizza, or pepperoni pizza, or veggie pizza, or all of the above pizza, meat supreme. For 45 people, just take a guess on how many pizzas that means. Wrong. Just ballpark, I'm thinking 15. Just ballpark. Some of us are very dainty eaters, you know that. Anybody know what a pizza costs?
Yeah, you can eat.
Well, you can get the tax
They just raise the price.
You get tax free.
Anyhow.
Depends on how well you like them.
Yeah.
How